Yeah, I need to do that. People. Hello, class. How y'all doing? Did everybody? All right. Did everybody sign the roll?
Yes, sir.
They say you got all day to sign it though, but go ahead and sign it. Anybody have any problems logging in to sign the roll or whatnot? Any issues?
No, sir.
All right. Okay. So what we'll do before we start chapter one, we're gonna look at what I'll do. I'll show you how to use the Visual C++ and write a program, and then show you how to add that header file. It might not be the same type header file. Well, it's gonna be a header file, but
Professor, I think you froze.
It's your class now.
Go ahead, something.
Professor, I don't know if you heard us, but yeah, you froze.
I think it's
He just disconnected. Should we like if he rehost it, is it gonna boot us out this meeting? Do any of y'all know that?
It said that Matthew is the host
He'll
now.
probably
Yeah.
be able to rejoin, I imagine.
Okay, that's what I was.
You should be able to rejoin.
Oh, bro, it's always the computer classes that have problems, bro.
Hey, it's your class now.
All right, guys. Today we're gonna go over computer.
What else? What else? What? I have a
Today's
question.
class, I'm gonna teach you how to play Rocket League. Any questions? Y'all
Hey, I
message
really
me.
don't know how to sign this
How do
role.
you
How do I catch
fly
up
in
to
the air and
Paul
hit the
so
ball?
fast?
Because I don't know how to do that.
Okay, wait. On a real talk note, who's the person that said they don't know how to sign the role?
Cole, me.
Okay, so look, you gotta register for the class first so go to home, and it's gonna be like on the top on the modules tab is like the
I just clicked register, sign role.
Okay, so if you're not registered yet, you gotta register for it and like sign up with your name, I think your email and some other things, and then it'll allow you to sign the role, and it should be like your first initial of your first name, your last name, and I think it's dash, then the last four numbers of your L number, then dash, and then 1. So that's usually how it goes to register for the role.
Yeah,
Okay,
the
but
call number is
I
like
don't
your
know- I don't
student
know.
ID number.
Yeah, I don't know what happened. I dropped. My network dropped for some reason.
Yeah, we saw Professor. You got DC'd.
Man, I tell you. Bro.
Look, I was telling everyone you left. I was like, it's always the computer classes that have the Zoom problems.
Right, that's what I'm saying. Yeah. Oh man. But so I was just gone. It was nothing.
Yeah, you were gone.
It
You
just
weren't
froze.
missing.
You
We
just
were worried
disappeared.
about you.
Wow, man, because I said, wait a minute, man. It's like it's trying to connect. Something wrong. Man, I don't understand. It's something going on, bro. I don't know.
Always.
Yeah. Well, let's go. Let's get started again. Let's go. We're gonna I think I shared. Yeah, okay. I'm sharing my screen. So what I'm gonna do is I'm gonna go back to visual. This is where I was. All right. So in visual,
Hey, Professor.
yes.
Man, AT&T is actually at my house right now working on my Wi-Fi, so I can't like sign into Roll. Is that okay?
Well, you got up until tonight at 12.
Oh, okay, that's cool. All right,
Oh, you could try to do it from your phone too or something.
Okay, I'll just do it whenever they're done then.
Right. Okay. Yeah, you got from midnight till the midnight. Yeah.
Midnight.
Right.
I got you.
All right. So okay, Visual Studio. All right, I gave you a program to write, and what I'll do, I'll just create a small program. All right. So in Visual Studio, once you install it, okay, I'm gonna click New Project, and what happens is over here you're gonna see all of the installed apps. You may have Visual, you may have Python, you may have what else? Java, whatever. But we're concerned about C++. All right. So you should see Visual C++. Click on it, and then you click on the desktop wizard. It should be the Windows desktop. And then over in this side, you will click the desktop wizard. Okay. So this will set you up to where you can work within the screen to do your work. You can give your project a name. I'll just say CSCI 1933. All right. And I'll just say, okay. But if you notice here, this is where it's going to create the folder. All right. It's gonna be under user David source repos. All right, and then it's gonna create a folder for the project called CSCI 1933. All right, click OK, and then at this point you'll click empty project. Okay, don't want anything dealing with visual in there. You know, visual has its own, you know, whatever uh libraries or whatever, but I want you to do just a C++, basic, the C++ library. So you choose empty project, and then you'll be able to take that file and use and upload it on any C++ platform. All right. So here you click OK. And once you do that, then you'll get this screen here, and you'll have this over on the right. Now, if you do not have this, sometimes, and like I said, many times, like if you have more than one person working on a computer, they'll change the Windows layout. So all you have to do is go to Windows and do a reset Windows layout. It's gonna ask you, are you sure? Whatever, you just say yes, and then it's gonna put the default window layout back up. And then you'll be able to right click on source, click add, and then new. And then now it gives you an option to create a C++ file, a .h, which is a header file, all class. But here the utilities is where you would go where you create a text file for a data file. But we'll learn that later on in the semester. So we'll go back to Visual C, and we'll choose a C++ file, and we can leave it as source. So source would be the CPP. Or I could make it CSCI test R1. All right, that will be the .cpp file. All right, look where it's putting it. All right, in that folder, in this path, the folder CSCI 1933. All right, 1933. So click add. So now, for blank file, blank document. All right, so now what I'll do, I'll just do a small program. Pound include, if I could type. Now, then I'll say using namespace, and then and main. And what I'm gonna do, let's see, I'll do something like int x equals 4, y equals 3, and say product equals 0. All right, so I'll do something like that. And then I could say product is equal to x times y. And then I could do a cout product. And then I could do product. All right, so now wrote a program. I could run this program and whatever. Now let's look at it. Let's do the breakdown of this program. Here I'm loading a library of IO stream, input, output. So that enables me to do input and output. All right. Well, in C++, the later versions, back in the day when C was kind of just getting off the ground and developing, you had all of the libraries every time you wrote a program, which means what? Your program could be very large because every library was incorporated in that C++ source code. So what they did was they said, okay, we're going to break it down to where the programs can be smaller. So what we'll do is, if a person only needs this particular library for these functions, we'll just allow them to load that, and then that will reduce their program considerably. Example, if you need to do something dealing with input and output, reading input and output files, you would do a pound include F string, right? Otherwise, if you didn't, you don't use it. If you needed to do something dealing with string data, you would do pound include string. But if you didn't need it, you don't put it. So what it did, it eliminated a lot of unnecessary files or code to be added into a program, which makes it a lot smaller, which makes it much faster to run, load and run. So that's the first one. And like I said, you could have multiple. There are pound include math.h. That gives you an option to use like the power function in math to raise a number to a certain power, or sine and cosine, stuff like that. So you have different options or libraries you can load. The using namespace and STD for the standard library. The standard library, if you ever looked online and Google, when certain people are writing code, they don't use this line. What happens is if you're going to use cout, then you would have to do std : All right. So it makes you have to use this anytime you're using cout and cn and some other commands. But if you do this, then your standard library is loaded and you don't have to worry about that. Okay. Either way go, your program will work, whether you use it or you don't use it. All right. Now, if you look at this portion of the program, this is your main function. Remember this, class, with C++, every C++ program has to have one main function, all right? The main function is more or less the driver, the starting point for everything in your C++ program, all right? So from this function, I could call other functions. We're going to get in that later on, but it has to start here. Now, what is a function? What does a function look like? All right. The function has a function header, which consists of a data type, a function name, and an argument list. Well, our name here is our data type we return in is int, which I don't have in here. So I have to do return and 0. I can return any integer, but at the end of the execution of this code, I'm saying in this main, I'm returning an int value. If I don't do this, int 0, int 1, int 100, whatever integer value, I'm going to get an error. All right. It just says that everything executed correctly and it got to this and it returned it for this part. Now, so your data type, your function name, so the name of the function is main, and your argument list. Right now, we just starting writing the code, so we don't have any argument list. We're not writing any other functions. We don't have any argument list. Later on in the semester, we're going to look at argument list and how they look and what they entail. Right. So now, the body, you have the header of the function. Now here's the body of the function. The body of the function begins with an open curly brace and it ends with a closed curly brace. All right. And then within the body, you have your code that you're going to execute. Okay. This is our initialization statement, initializing your variables. This is a assignment statement. You're assigning product to equal X times Y. And this is an output statement, a cout statement, which outputs the word. What they're going to do: 2 lines, tab, print out product : space, and print out the value of product, and then 2 more lines, and then return the 0 to end the program. So let's run this. So to run this, we do a build, all right, and we compiled it, okay, to see if we have any errors. It says build 1 succeeded. So everything went through, all right, no fails, all right. So now I can go in and debug and do start without debugging. So that would have been a Control F7, Control F5. I think Control F7. Yeah, Control F7, and this would have been Control F5. So now, where is my output again? Let's see something here. All right. So if you look at it, it went down one line, went down the second line, tabbed over, print out the word product, colon, space, and printed out what 4 times 12 was. 4 times 12. 4 times 3 was to give you 12. And then it space 2 more lines. And this is just output from the compiler. All right. So everybody see that's just a regular program that was created. Now, I told you to add a header file, okay? A header file. Well, let's first create a header file. All right, we're not gonna add it in yet, we'll just create it. So I can go to header file. I could have done it from source, but I can go to header file, right click, add new, but still I need to choose what? Header file. Now, I could change the name here if I want to from header.h to anything I want, okay? But it's gonna be .h, all right? So whatever it is gonna have the .h. So I'll leave it as header, okay? And hit enter, all right? Or hit there. So now, you can leave this in, it won't cause any issues. I normally take it out, but it from my previous courses, they were saying it carries over some information for whatever, but it doesn't really change anything in the program. So what we'll do here, we're going to create a function, all right, or a program with a function in it that's going to be that's going to be used in the other program that we created, all right? So to start this program, what are we going to be using in this program? Well, I'm going to output the course name, the semester, whatever. So I'll do the pound include IO stream, all right? Because that's what's going to be going on in this program, okay? Using namespace. Okay, so I'm gonna load the standard because I'm gonna use the C out in here. Now, what did I tell you about a C++ program, a function, the main function? You can only have how many? One, right? This header file is pretty much an extension of this file. So you cannot name it main. You cannot use main, all right? Everybody understand that? Main is going to be the driver program. So I could call it main 1, I could call it whatever, but I cannot call it main because the compiler looks at main as being the driver, and you can only have one main function. So I could call it whatever I want. I could say void. Now, and I'll talk about that void in a little while. Head, okay. And now, so what I did, a function header and the body. Everybody understand it? Here's what I'm loading. I'm loading the library. I'm loading the standard library, and then header. Now this function header, it has void as a data type to be returned. What that means is I will not have a return 0 or return anything. Void means there's no return. Okay, so if you put return whatever, return 0, anything, return whatever, you will get an error because you're saying void. There's no return. So what I can do, I'll say cout, and I'll do //t. I'll say all right. I'll just say Baton Rouge Community College. And I'll do a inline. That takes me to the next. I'll do a out. And I'll do what this is. Programming 1. All right. And then I'll do cout. Okay. So, all right. So I just have these lines. All right. And I'll just put another line at the end. All right. So this is my program. I mean my header file. So now it's created. It's called what? Header.h. Now, how do I use this file in my program? All right. Or not even the file and also its contents. In order for me to use this file, all right, what I'm gonna do here, I'm gonna come here, I'm gonna take this off. And what I'm gonna do, I'm gonna use double quotes and use header.h. Not the less than greater than symbol. Everybody understand that? I have students who try that. What they do is, oh, Mr. Vest, it work. No, it doesn't. You have to use the double quotes around the header file name because it's a user-defined library or header file. It's not something that's within the system. It's user-defined. Everybody understand that? You defining this header file. So you don't use the less than greater than symbol. Now, and I think I could take, no, I need this. I think I need this for this file. Now, you say, well, Mr. Sylvester, I'm outputting data here. Why did I take out IO stream? But once I load this file, it's going to take this library that I'm loading here, and it's going to be a part of this. Everybody understand that? So any library that I load here, whether it's F-stream, whether it's string, whether it's math.h, whether it's vector, whatever, when I go to this program and I have this as header.h being called into there, all those other libraries are going to come with it. Okay? So now, so I have my program. Now, I can run this program, it'll run, but I still will not get the execution of that function that I have in the program. And let's run it. So if I debug it, I will build it with Control F7. It succeeded, and then I do the debug, and what? I'm gonna get my output, but I did not get what? I did not get the what? Baton Rouge Community College System Programming 1 and Spring 2021. How do I get that? In order for me to get this here, I need to call the function that's in the header file. I've loaded the header file, all right, and all the other headers that libraries that was with it. But now I need to call this function. Okay. Now, basically, this function don't have any arguments. So I'll go back to the program, and whenever I want to call it, I could call it at the beginning of this, the start of this program, this main function here. I could start it right before this C out here, or I could start it right after that C out. You understand? I could call it anywhere in my program. All right. So let's call it here. To call it, you just simply type the function name, and there's no argument list. So I'll do head, semicolon. Now what? I'm loading my library, all right, which is this my defined library. Then using namespace, loading the standard. Okay, in my int main, it says, okay, I've loaded the library. Okay, this library has a function called head in it. So let's see what, and it says, go ahead on and execute head. What head has in it? I'll put this, well, 2 lines, tab, I'll put this, let me put a /G here. Tab, type that, a new line, tab, type this, and 2 new lines, okay? And then it's gonna output, well, 2 more new lines, product, and then 2 more, and the actual product, and then 2 new lines. Okay, so when I run this now, okay, well, let me debug it. I'll go through the debug stage. Everything's good, and then go back to the actual compiling it or debugging it really. And it should have came up. I bet you it's still. I think it's up, but it's down here because I didn't. So see what happened? See how this information, which came from where? The header file was called by using this head function, and then it continued on executing my program. Now, I'll show you something. I've created the head. Now watch this. I could even go down here and call it again. I could call it as many times as I want. So this time, when I run it, it's gonna appear what? Twice. You understand? Before, okay, this is here. Okay, the head. What is head? Baton Rouge Community College, System Programming 1, Spring, whatever. 2 lines, then 2 lines before this, product, and then what? Well, 2 lines after, and then call head. What head was? 2 lines, then Baton Rouge, System Programming 1, Spring 2021, and then 2 more lines. So everybody see what happens here. I could call it anytime I want to. All right. So what happens, and what's a good way? I mean, a use for it. If you had a company and you had a particular header or footer or some kind of message, whatever that you wanted to consistently output, and maybe want to use for every programmer, you have that maybe in a storage area. Create your own little header file, have that in a storage area, and have them load that header, and then what? Call that function whenever they need it, right? Everybody understand that? So anybody have any questions about how to put it in their program? Because I want you to be able to put it in your program when you turn in your assignment, all right?
I have a question about headers.
All right.
So, let's see. In the header, it's you have the include IO stream,
Uh-huh.
and in that. So I see that you have using.
I think I could take it off too.
Okay, that's what I was gonna ask. If you can
think,
just put all that stuff in the header and it transfers over.
Yes. See, right. Because see, what happens is you load, and remember we talked about, before I said we had when C was first being, C++ was first being developed, they had every function or every library, every time you ran just a simple program. So now you can create your own segments and have your own segments and create and have it reduced to just what you want. All right, and you just call in whatever one you want. So what happens is anything I have in here, and I call this function, it's automatically brought into this one. All right.
Is it a good practice to have all of the includes and the namespace standard and stuff in the header?
It depends. Now, I'm gonna show you. I'm gonna tell you why. The reason why. Say, for instance, you may be debugging your program, or for instance, the storage area for these header files get corrupted, or you can't access them, right? Then therefore, what? This program can't run. You understand? Now, I would say the advantage would be to have everything over there because what? It reduced the size of your program. You understand what I'm saying? But you got to realize that too. When I don't have this, I have to list every function that I had. I mean, every library I had previously in my other one, or something gonna go wrong. You got what I'm saying?
Okay.
But then
the
head won't work.
File has an issue. Then
right. But I would say for us, being that we have a small program, it would be best to like have everything in that one, and then just have this one and it work. You got what I'm saying?
Right. So if you did do it redundantly, it would just mean that if the header file doesn't work for any reason, the program still does, and just
right. That's right. You could still take that program independently and run it on another platform without that header file, and it'll work. Well, minus what? Taking this out, because I still would have to what? / this, because where's head? Right. Head is where? In here. Right.
So it would have an error anyway.
Right.
Gotcha.
Right. Because if you pulling any functions or whatever from that header file, yeah, you're gonna still get it. But you'd have to comment that out. Correct. Right. Now I say for us, it would be cleaner if we would just, like you say, okay, I'll just put everything here, and then this gonna call my header file, and boom. But like I say, you gotta remember, if you just try to run just this file independently, it won't work. You would have to have this file, for it to work. All right? Because watch, let me change this. I'm gonna just change the name to let's say you're not even reading. See here, it doesn't know where header 1 is, so you're not loading our stream and you're not loading head, so you're gonna get all those errors. You understand? You get all those errors. But like I say, you don't have to use this. You could do what? Include IO stream, and then you can do using namespace. But what? Now
won't work. Yeah.
Right, I have to comment that out. Correct. Because it's not being referenced. Right. It's nowhere it's being referenced in the program. Yeah. Hold on, class. Duct tape. Oh boy. Hello? Oh, yeah. I was in class. Yeah.
Oh, okay. She just needs to say.
All right. All right. Thank you.
All right. No.
All right. Thank you. Man, I'm back, class. All right, so everybody understand what's happening, and everybody know that in order to bring it in, you got to use the double quotes. And look, if you're in visual, when you do that double quote, if you already have that header file created, you could just double tap on it, and it'll bring it in, knowing that that's the name of the header file. All right. All right. Questions? And look, no semicolon. Remember, no semicolon at the end either. All right.
Sir, Haley had a question in regards to using iOS stream, like
okay.
Output stream. She said so you don't have to use it
twice. No, not twice. Okay, you have to use it because what? It's used here. Remember?
Mm-hmm.
Now, because watch, I'm gonna just show you another one. I'll say, I'll do this. I'll go back here. Show you the error first. If I do something like this, I'm gonna take this off. If I do string, say name, month, I'll just say month, is equal to, all right, say month is equal to January, all right? So now, I'm gonna get an error here because I didn't load the string library. So let me do a debug or do a build, and I should get an error. It built it. Why did it build it? Unless the visual incorporated the string. But normally what happens is with string, you have to, man. And just because I tried it, pound include. You normally have to do pound include string. All right. In order, if I could tell you. All right. You do the pound include string, and then that would make this string variable valid. You understand? But for whatever reason, it pulled it in and it made it and used it as a string variable, which it shouldn't have. I might have to use something else. Let's see. No, it worked. But let me try this then. And niggas say just making me up to be wrong, but it should work. It shouldn't have worked. So I'll take that out, and I'll do a mat. I'll say let's see. Let's see. Let's see what it is. Equals POW. I'll do int, my fault. Grab POW 4,3. And, all right. So, and it's still working. What happened? It shouldn't have worked. And it debug, and it ran. And class, I'm telling you, you're gonna get errors. It's working now, but I'm telling you, you're gonna get error. Let's see, debug without. Well, I didn't even output it. I didn't even output the value. And I'll do. What this is. SQR. And it shouldn't have worked, class, but it's working on. Like I said, could have updated it since the last time. Yep, and it's doing it. It's doing 4 raised 4 cube, and it's giving it to you. And we're gonna be in the book, and the book gonna tell you got to use it. But let's not worry about that now. It's working that way, but you're gonna have to use. I'm telling you, you're gonna have to use it. Let me see something. Okay, it's still good. Everything's still good. Everything is still good.
I mean, if you look down, even though it's working, it's giving you a warning.
Right. Yeah, but that's Right. Yeah. Oh, so I got this error this time. Headphone, no, but that's because I took that out. But no. It shouldn't have worked though, man. But we'll deal with it as the semester go on. But that shouldn't be right. But it's working. So they don't kind of upgraded the C++ to where it handles that. So that's good. It's good in a sense, but it kind of makes you lazy as a programmer where you don't have to worry about those libraries. But like I say, it's okay. So, but any questions about the header file? Like I say.
No, sir.
All right. So everybody gonna have my program already. All right. So let's look at the chapter 1. All right. Chapter 1 is just the introductory. And if you took 192, the 193 introductory is basically the same. It's similar. All right. Everything is similar. So let me move this over. All right. Okay. So now, 193. All right. Why programs? So why would you think we use programs? Why would we need programs? Programming. But the number one reason programs run the same always, in that once you write code, it's going to do the same thing over and over and over and over again based on the logic you give it. Whereas we as humans, we might do something one way one time. We might be tired the next time, and we might overlook something, or sometimes we might say, "Oh well, I'll just let that person have whatever." Like say if it's a loan and they don't really can really afford it or whatever. But the computer will do what? The same thing over and over. The computer will be more efficient. The computer can handle more volume than humans. All right. And it can do multiple jobs at one time. Whereas we have to pretty much stick to one thing, kind of maybe complete it or start it, stop it, whatever, which takes us more time to do. So computers, like I say, they become they're more reliable by us because what they can do multiple things for us and keep the data, keep us on track and whatnot. So it's a whole lot that computers do for us that helps our day go by. All right. Because many times, what if we didn't have an app to go and look at our bank statements, we wouldn't know how much we had in our account to do what we need to do. So stuff like that. We can guess, but many times when we guessing, we guessing wrong. All right. So computers can do such a wide variety of things because they can be programmed. Okay, this means that that computers are not designed to do just one job. All right, and I'm looking at this second paragraph. Okay, but any job that the programmer tells them to do. And what's a program? We just looked at a program here. A program is just what? A set of computer instructions, right? That's all a program is. Set of program instructions set up in logical order, right, to perform a task. That's all a computer program is. Now, they have some that are larger than others, yes. Or more complex than others, yes. But yet and still, from the simplest to the complex, they still what? Are computer programs. All right. Programs are commonly referred to as software. Now, we know that software is very, and the book say essential, but it's very important when we have hardware. Hardware cannot function without what? The software. Your cell phone cannot function without the software being written for it. Even cars today cannot be driven without software written for it, because there's so many different type sensors and whatever on cars today that, like I say, the computer go bad, your car probably won't even start. And many other devices that we have, depending on the software. Well, the software makes the hardware do what it needs to do, right? So when the programs are written, it's normally called software, right? Programmers write this software. Programmers can also be called program developers, all right? And normally in a larger environment, like say Microsoft, you might have programming teams, all right? You don't have like one person working on a particular module or whatever. You might have a team that's working on that module. So you have a team working on one part, a team working on another part, a team working on another part, but they all working together to put this together, kind of like we did with our header file. Somebody will work on the header file, somebody will work on the main program, put it together, and it should what? It should work. All right. So and what it does, it reduces the processing time, the time it takes to create something. All right. So computer programming is both an art and a science. Now, many times people don't look at it in that fashion. They look at, oh well, you just go ahead and type some stuff and it's done. But if you look at it from the aspect of trying to create something, all right, it's an art, because what you're taking a situation and you're trying to develop some software to cater to that situation. Kind of like an artist. An artist take what? You could say, like, say somebody do sculpture. They take a piece of material and then they sculpture it to become, their final project. All right. That's the art of it. But then it's also a science, all right? Because what? You have to logically come up with that design, making sure that what? Each step is the proper step. So that's what making a science. You can't just say, oh, I'm gonna put this together, boom, it's done. You have to sit down, logically work it out, and do your research, then work it out as to how it's going to be developed. All right. So it's an art and it's a science. All right. It's an art because every aspect of a program should be carefully designed. Okay. Listed below are a few of these things you must that must be designed for any real world computer program. Right. The logical flow. Step-by-step instructions. Give an example. If you telling somebody to go to a particular, say, store, or even if you look on your GPS and they got turn by turn, and if one of those turns is the wrong way, you can end up, in another city or another state, right? Mathematical procedures. So now you got to make sure all your computations and everything are correct or accurate. So you got to know a little bit of math. Like I say, you may have to do a little research to know how that mathematical expression is to be developed. Because what? As a computer scientist, you might not be a chemist or physics or somebody in physics. So you might have to work with them to what? Formulate your expression to fit what they need that computation to be. All right. What your screens look like. Many of you got apps on your phone. What? The apps have to somewhat be appealing, be readable, and be more or less user-friendly, because you don't want to have to scroll like say 50 times to get to, oh, please verify this screen or whatever. So stuff like that, you as a user, the programmer, you have to be involved in how this stuff should be or whatever, or either present it to a group and give your stance on why it should be the way you want to design it, particularly in that fashion. So the way information is presented to the user, all right, you designing that. So even though we in these classes are just designing code to work and to get the proper output, as you develop your programming skills, you're going to learn that, there are going to be some preferences, some things that you're going to have to make decisions on, being that you are at that level and that hey, this should work because, users like XYZ, or users should be allowed to XYZ. They should be allowed to go from this prompt to that prompt to that prompt to that prompt, or whatever. You'll be able to make educational decisions on that, wise decisions. Programs to be user-friendly. Now, many times as you grow in computer science, you may get biased as to what you do and how you develop your programs. But in order for your product to sell, you would always want to be conscious of how the user will accept what you're trying to develop. Because what? Anything that's hard to use, users may not even try to use it. Take an app. You might download an app. If this app is so cumbersome in that you got to put in your password 3 or 4 times, put in this security question, then come back, put another password. a person might say, well, nah, the app, the software itself is good, but what? The security part of getting in is too cumbersome. I'd rather use just something that I can just type my login in and I'm straight. So, you as a programmer, you're gonna be able to determine what's considered, user friendly to you and what to do. Now, there's one thing here, and normally I deal with it with my other class, my next class, the 190, when I teach 194, manuals and other forms of written documentation. Now, in these classes, I don't deal with it that much, but anytime you design something, you should have supporting documentation, whether it's a user's manual, whether it's a programmer's guide or something, because I'm gonna tell you, many times people design something and it's great, it worked great, it looks great or whatever, and they don't have any document. Oh, I wrote it, I can write it, I do whatever. But then they start and they write other code and other projects, and then they have to come back to this one project and do upgrades. And then all of a sudden it's like, wow, let's see, what did I do here? Why did I use this variable here? What I'm gonna do with this and how? So you don't have any kind of documentation as to what you did, what this was done or whatever. So it's almost like you gotta start back from scratch, line by line, looking at your code, saying, okay, this is this is this. Oh, why did I do this here? What's going on here? Oh, I did this to do this. Oh, so you're almost relearning that particular code to what? Try to upgrade it. Whereas if you had documentation, oh, this variable, oh, it's used for whatever. Oh, it says that it's going to be multiplied by whatever so that I can get the value here to add to whatever. And now you got some written documentation so you can follow to kind of keep you abreast of what's going on rather than trying to look at code and figure out what's happening. So documentation is important. We won't have to deal with it this semester, but next semester, if you're in my class, we're going to be dealing with documentation with your program. And students will tell you, some of them, Mr. I got the program, but the documentation taking me as long as the program to do. Because what? You want to make sure it's right, make sure everything's in order, make sure it's in its proper place and all that. So documentation can be tedious. And they have teams for that. Many times you have a team for documentation when you're doing a program. Now, there's also the scientific or engineering side of programming. So that's the science side. Because programs rarely work right the first time. And as you get involved with writing code and writing larger scale programs, you're gonna understand that what? Sometimes the first time through, it just don't work. So what? You gotta go back, test it, go back. Sometimes you might have to go what? Redesign it from scratch all over again because you're like, man, I started this with this, but I'm gonna scratch this. I'm gonna go another route and try to do it. Sometimes that happens, but that's the science of it. Going through that and designing, redesigning, testing, making the corrections and whatnot. All right, but that's programming. And I tell a lot of students, if you do not have patience, if you cannot sit down and look at the screen, study whatever, look at your documentation, study whatever. And like I say, sometimes get frustrated, come back at it, work it. You're in the wrong field because computer science, everything don't just work just because you just follow this 1, 2, 3 step. You're going to have times where, and if you look at it, look at some of and this is more or less a different type area, but basically the same thing. When you look at your network IT guys, what happens? Network working fine. Network working fine. Network working fine. Network working fine. All of a sudden you hacked. Then what you got to do? You got to bog down and figure out, first of all, how you was hacked, when you was hacked, fix the hack. You know what I'm saying? So it becomes a whole lot. And if you don't have that intuitiveness of grind and do, you're in the wrong field. Because it's gonna come a time where it might take days for you to figure something out. But not just sitting there and looking in the sky. I mean, getting on the computer, trying this, working on this, adding this, doing this, and eventually getting it, you know, and you have that gratification of, wow, got it done. Let's move forward. So, like I say, computer science, it's a tough field. It's not hard, but like I say, it's grinding. You got to have that desire to want to go, want to move, want to keep doing. Hey, you got that stumbling block, but hey, I'm gonna still push forward. So, like I say, reach out to all resources. You know what I'm saying? And when you even in a work environment, you might have to reach out to somebody. Hey, you worked on XYZ project. I'm on this project. How did you overcome whatever? So you got to be outward. You can't be an introvert where I'm gonna figure it out myself. The time it takes you to figure it out yourself could be a week, whereas you could have talked to a coworker and it takes you 2 days. You understand? And that's that much time you have to move on to the next project or do, you know, get your project done in a better manner. But like I said, that's just some insight. But computer science, like I said, it's grinding. So hardware and software, we should know that what? The hardware is the physical equipment. Software is the program that's written to make that computer or equipment work, right? Basically what it is, all right? And like I say, hardware devices, you got your CPU, which is the central processing unit where all information is being processed. You got your main memory, which is your RAM, all right? That's where everything is resident that you're running. And then you got secondary storage, which would be all of your drives, where your floppy drive, hard drive, USB drives, external drives, etc. CD-ROM, CD drives, all that. That's your secondary devices. But then you have input devices and output devices. Input device would be any device that is used for the purpose of inputting data into the computer. Output devices are any type of devices that are used to receive or retrieve data from your computer. All right. And this is just a little chart that should give you an example of some of the different devices and how they're classified. Well, you have your CPU. Now, most CPUs will look similar to this. All right. And notice at the bottom of here is a heat sink. Because why? How would I say it? Information is being processed. The faster information is being processed, the hotter your processor gets. Kind of like taking your hand, or kind of like being on in a tree and you're sliding down a rope. The faster you slide down that rope, the what? The more likely your hand will get burned or get hotter, right? And it's the same as information. As information passes through that processor, the faster it goes. So what they're doing, the faster computers are being made to process data, the more heat sinks they're gonna have to put in to cool it down, because it causes heat. And if you notice, they got these are heat sinks at the bottom. If I can see here, this is a heat sink, but this is the processor, and it clips out, and you could clip another one in there. All right, and this is the memory. Normally, this is called SIM chips. All right, but this is your RAM memory, and in a laptop, they might be a little smaller size and a little thicker. But like I say, because a laptop is more condensed, but yet in the same, you could see it as the RAM memory. RAM memory holds data so that we can multitask. All right. Input devices. Here you have what? A webcam. The video is fed into the computer. A joystick. A joystick can be considered a mouse, right? Because when we play in a game, whether it's a basketball game or whether it's a car racing game, that joystick controls what? That car as it travels. So, and when you use your mouse, you controlling that mouse and how it travels. So when you are in that game or on that race car game, the car is the cursor, right? And the joystick is the mouse. So that's the analogy of it. So you have a keyboard, you have a mouse, you have a scanner which scans data into keyboard. You know you're typing data, and the mouse, you know you're clicking or selecting and doing something. Your camera, you can connect your camera or your phone into your computer, and data can be sent into the computer. And then you have like a notepad. Those notepads you can be used to highlight certain areas on the screen or whatever. So those are input devices, anything that can feed data into your computer. But and looking over here, you see these monitors. A monitor can also be what? An input device, right? Just like your cell phones. Your cell phones that are touchscreen, what? The monitors are input devices. Computers or laptops that have touchscreens, those monitors, as well as being output devices, are also what? Input devices. All right. So your monitor can be an input or an output device. All right. And another input device they could have been mentioned is the microphone, because your microphone or receive the voice or whatever sounds that's being that has been displayed at that time and is read into the computer, and then you can what? Use the speakers to what? Output it. So speakers, the printer, output hard copies, and monitors, those are output devices. So you got to understand input devices, output devices. Your storage, you got your main memory, which is your RAM, and your secondary. Now, main memory, this RAM says, and what the books tell us, that it is volatile, meaning that as long as your computer is turned on, it's available for use. All right. If I load a Visual Studio, it has to go through RAM, and now it's loaded in RAM. I can use it whenever I need to. I can click back and forth on it whenever I need to, as long as I don't exit out of the application. All right. When I turn my computer off, the RAM is wiped out, and I'm starting anew when I get back on my computer. All right. Now, secondary storage, such as the hard drive, CD-ROM, jump drive, floppy drive, etc. If I save something to that floppy drive, to that hard drive, if I turn the computer off, that file is still what? Located on that device. So that's the difference between the main memory and the secondary memory. Secondary memory, you will always have that file, and you normally could take that file and use on another system. All right. It's not deleted. All right. So here talking about the CPU. And like I say, that's what all the programs go through to be executed. All right, we talked about it. Here's showing you an image of what a computer would have looked like back in the day. All right, it took up a whole wall. It said weighed 30 tons. And like I say, look what done happened. Now you have a chip as small as this that can do more than what this did. But evolution, like I say, as time goes on, what things become faster, smaller, and more precise, more efficient. All right, and that's just hopefully things will always be that way, so that we always advancing rather than digressing. All right, so that would be like that CPU chip we was talking about. All right, now it tells us the central processing unit have two parts. The arithmetic logic unit, that's where all of the mathematical calculations are done. and then the control unit. All right. So anything that's mathematically calculated has to go here, but everything runs through the CPU. All instructions, all of your instructions. So when you buy a computer, you notice they talk about what? CPU speed. They talking about the amount of instructions that can be executed in a given time. All right. So it says a program is a sequence of instructions stored in the computer's memory. All right. When the computer is running a program, the computer is engaged in a process known as fetch, decode, and then execute cycle. So what? It has to get the information and then actually store it in memory, or from the memory, main memory. Because what? Before a program can be executed, it has to be where? Loaded in main memory. Any device that you have has to have main memory. It's almost like you have to have a brain, to function. So the computer has to have main memory in order to function. If you take the main memory out of any computer, it won't boot. They will not boot up because what? Nothing will, the instructions, the operating system or whatever won't be able to be loaded there in order for the computer to know how to operate. All right. So, like I say, the CPU, all of the instructions are executed down. And like I say, your processor speed is determined by the amount of execution, number of statements it executes in a certain amount of time. All right. All right. The decode, fetch, decode, and execute. That's the steps that's followed to actually perform the reading of those instructions. Main memory, we talked about main memory is dealing with RAM, random access memory. That gives us the opportunity to what? To multitask. I could be on the internet. I could go into a Zoom, click on my Zoom session. I could go and click on the Word document. I could go and click on something else. But all those programs must be resident in RAM at that time. Otherwise, I wouldn't be able to do that. All right? Okay. Now, it's talking about bits and bytes. The computer memory is divided into tiny storage locations known as bytes. Now, what is a byte? Well, how would I say it? It's a byte. Bytes are every individual character that can be typed into the computer. Everybody got that? A space, the number 2, the @ symbol, the letter N, a control key. Which are non-printable characters. Every character that can be recognized by the computer is a byte. Okay. But let's stick on bytes. So let's take BRCC. BRCC is how many bytes? The letters BRCC. How many bytes is that? Each character is a byte. Huh?
4.
It's 4. All right. So any character is a byte. BRCC is 4 bytes. You understand? 4 characters. But each byte is 8 bits. So now those 4 bytes of BRCC equals how many bits?
32.
32 bits. So you see what's happening? Because we said, well, Mrs. Lester, so why are we concerned with bits? We're not really concerned about them because the computer does everything. But at the same time, we need to understand that information is not stored in the computer as we see it. Information is stored in the computer as what? Zeros and ones. Everybody understand that? The computer can only understand zeros and ones. When you have a picture, the computer only sees what? Zeros and ones. When you have a audio sound, the computer only understands it as what? zeros and ones. So you understand when you write a program, like the program we wrote, pound include whatever, int main whatever. But the computer only understands what? Zeros and ones. So the computer does not understand anything but zeros and ones. So it tells us here, each byte is divided into 8 smaller storage locations known as bits. So we talked about that. The 4 bytes ended up to be 32 bits. The term bit stands for binary digit. All right. So that's a bit, a binary digit. All right. Computer scientists usually think of bits as tiny switches that can be either on or off. All right. So 1 or 0, on or off. All right. So computer scientists think of a positive charge. Think of a positive charge as a switch turned on, and a negative charge as a switch turned off. Right? Each byte is assigned a byte. Now, remember what I said. Each byte is assigned a unique number known as an address. The addresses are ordered from the lowest to highest. A byte is identified by its address, in which the same way a post office is identified by its address. All right. So look what it's trying to show you here. The number 149 is stored in a cell with the address 16, and the number 72 is stored at the address 72. So what happens, you have your addresses. But let me show you something, how the computer looks at those numbers. If I do something like ASCII table. Let's look at the ASCII table. All right, get this one. All right. So we look at we look at the ASCII table. All right. Okay. All right. We look at this ASCII table. Let's look at the letter A, okay, which is because I think the book will look at it too. Look at the letter A. All right. The char value, bytes, that's the byte. So letter A is what in decimal? 65, right? All right. So the char value is 65. The computer stores in the computer, when it sees a capital A, it does not store the letter A. It stores the number 65. The number 65 is converted for the computer to understand it into a binary number. Now, so let's look at this part where we say the computer stores it as 65. Let's go back to our program here. Let's look at this program. What's going on? There we go. All right. So let's look at this program. We'll take this out. And what I'll do char, all right, letter equals single quote equals capital A, right? Now, I'll say int let equals letter, all right? Then I could say cout I'm gonna say int value. All right. So now what I'm gonna do, I'm gonna output let. All right. Because the computer does not store the letter A, it stores the number. So what I did, I declared a variable called letter to be equal to A. But then I said, okay, give me that integer value of letter and put it in let and then output it. So let's run this and see what happens. Oh, no. Whatever. What happened? Unable to start program. Let's see. Let me run it again. All right. So look what happens. It output what? 65, right? So I just told it letter is equal to the letter A, but then take letter and output the integer value, and the integer value is 65. So you see that ASCII table allows you to see any and all of the values, even if I put not a backslash, but the regular slash, all right? And if I do a debug, it's gonna give me that value of that slash. They should have. Let's see here. See here? 47. So you understand what happened? Each byte has a numerical value. And then the computer says, okay, I'm going to take that numerical value, I'm going to convert it into a binary value, and then it can see it as that binary value. All right. So if we go back to our notes. All right. So here it says that we don't went through it really. So frequently used programs are stored in secondary. That's on the hard drives or whatever. So we can pull it up, just like our C++ program. It's stored on secondary storage, so we can later on come back, open it, do whatever we have to do to it. So that's what this is talking about. But we talked about this, the addressing, and how a byte is stored in an address, but it don't use actual letter, it stores those numbers. All right. We talked about floppy disks, CD drives, and hard drive being secondary storage. We talked about input devices, and we talked about output devices. All right. We talked about software. Software is used to control, not to control, but to manage or control the system, whatever hardware system. Now, software has classifications or different categories, and then you could break them down into multiple type categories. But still, you have system software or operating systems. All right, we know that on Windows-based systems, we have Windows 10, we have Windows 8, we have Windows 7, and all this. We have Linux, Unix, etc. Those are operating systems. Mac OS, operating system. A phone, Android, an operating system, has a certain operating system. But even when you have operating systems, within those operating systems, you could have or you could purchase utility programs, all right? These utility programs are used to, how would I say, kind of like manage or allow the system to keep working at its peak performance, all right? Sometimes you have software like defrag. Defrag goes in and defrag your hard drive and put all the files in the proper place from beginning to end, so it make your system runs a little faster. Backup programs, backup and restore, software. Those are utility programs. Then you have software development tools. Now, software development tools, exactly what it says. Software that you can use to create or develop applications or whatever to use within an environment. All right. But then you have application software. Application software would be any software that you use for your purpose to complete a task. Microsoft Word, application software. Notepad, application software. Something like a video editor, application software. So any software that you buy, outside of something to use to maintain your system or to keep it fine-tuned, normally would be an application software package. All right? All right. Why programming? Okay. Well, computers are designed to follow instructions because what? If we on a computer, most times the programmer forces us to put in the proper data. Now, we won't get into that in this class, but many times what happens if a program is written and the programmer say, please enter an integer value, and you enter 4.5, it should be something that says 4.5, and that's to that effect. 4.5 is not an integer value, it's a float value. Please enter a whole number. You know, so what you're doing, you're letting the user know, hey, I asked you for an integer value, you gave me a float value. All right. Or you type in, it asks you for an integer value and you type your name. And it probably should read your name, output your name and say, the name, or say BRCC. BRCC is not an integer value. BRCC is a string value, so you should write code to where it's going to, the code will guide you to make sure you give it the information needed. Because what if you write code to where a program can accept bad data, then what's your output going to be? Bad results. All right. So most programmers are going to write code to where what you have to stick to what they want, and if you don't, it'll going to give you the message, hey, please enter whatever, please enter whatever, and then it might give you so many times after that, oh, we kicking you out because you couldn't follow whatever, oh, you had so many attempts, like they do with passwords. All right. So it also waits for the user to enter the number of hours or whatever. So what? It prompts the user to input information, all right? Displays messages on the screen, all right? Multiply the number of hours. So, well, this is for gross pay. And so what it's saying, this is some of the things that this program may use, all right? So this is more or less the pseudocode that's written for this particular program, all right? So, but the program is instructions. Okay, this will display the message. How many hours? Hours should be what? If it's float or integer, hopefully you should tell them what data type it should be. Because what? You don't want them to guess, or you don't want somebody to say, oh well, I work 4.3 hours, but I don't know if I'm gonna just put 4. No, you give them examples, or you either tell them. All right, but these are instructions. They're showing you of pseudocode of how a program could be, first of all, started out and then eventually be written. And these steps here, this pseudocode, is called an algorithm. It's just like if I ask you, well, how did you find the product of two numbers? Well, first of all, you take the first number, you multiply it by the second, and then you get the product. That's the algorithm. The steps that it would take to do something is an algorithm, right? The logical steps that it takes. That's all an algorithm is. And it says an algorithm is a set of well-designed, well-defined steps for performing a task to solve a problem. So you telling somebody how to turn off a light bulb. What are the steps? That's your algorithm. So an algorithm is the defined step-by-step process to solving a problem. All right. So now,
I hate to cut you off. I'm sorry, but what does this class end at 1:15?
oh yes, it does, and I'm steady going. Yeah, okay, all right, yeah. Yeah, I'm steady rolling up. All right. Okay.
I wasn't saying anything. I was
just vibing. Look, for real, I was just vibing.
Well, I have another class, so I was like, does this class end?
Yeah, it does. It does. Remember, I think I told y'all that when I did my syllabus. I said I'll start rolling because man. All right. So, man, yeah. All right. And so what we'll do, we'll pick up on next class period. Let me see something else. Let me see if I got something for you in here. Let's see. Let me go back here. I don't think I have a quiz or nothing. But everybody got the assignments though. The assignments due tonight, I think, huh?
For is it in regards to the header, or is it
right?
So we have to do the header portion from program 1 and 2.
Right.
Okay, I got
Right. Well, yeah. See here, it tells you where it is. The header. See, also refer to the header of file for assistant. You know.
Okay.
So it's like you started the program. Hopefully, you started it, worked on it, but we didn't go over headers. But I wanted you at least to get the program working. You know what I'm saying?
Mhm.
And now all you're dealing with is what? The header,
Mhm.
right? So make sure you have your header because I'm gonna take off. You know, so make sure even if you got to resubmit it, I'll take the latest submission. So make sure you get that done. So so make sure that's done. Next class period we'll take up from where we left off. And what I'll do too, I created a link here, and what I'll do once I get the video, then I'll create this playlist, and you'll be able to see the lecture for today. So you'll be able to go back and review how to put the header in from what we did earlier in the lecture. All right. Yeah. Okay. So yeah, I don't have no other quizzes, but we'll probably have a quiz on next class period on variable names. But we'll go over variable names. We should know what are the rules for variable names, but we'll go over that, and then I'll give you a quiz. But I'm gonna let y'all go to your next class though. But like I say, all you have to do is do your assignments. All right.
All right.
All right.
Thank you, Professor.
All right. Have a good one.
You too. See you next week.
All right.
Question after class.
Oh yeah, no problem.
Should I do that right now?
Yeah, it's good.
All right. So let's see. It's about another class that I have that
Which
I'm in
one?
your class. So I'm in the micro comp.
Oh yeah. Let me go to that one. I know what you're talking. The 2203.
Right. So one I think I forgot to assign the role last Wednesday. So
I could add you.
Okay.
Yeah. But you did do the registration of it.
Well, okay, so my question was the SimNet, it has 3 different options for
Right, okay.
how to set up to it, and I need to know which one I'm supposed to
Now are they SimNet 2019?
I
They all
say the same, just about the same thing.
Right. I think one of them is without the text or something like that, huh? $85, I think, is without the text.
Okay, so there's 2 for $85. I'm looking at it right now. 2 for $85. One of them has a bunch of numbers before SimNet, and the other one just says SimNet, but they both say the same thing.
Bunch of numbers.
Yeah, so 12649040088 SimNet 365 2019. And then I can show you, I think.
Yeah, let me
get like a screenshot real quick.
Yeah. You emailing it to me?
I did email the question to you before.
No, the screenshot. Yeah.
And I did have a screenshot in that email, but I can send you the screenshot right now.
All right, then let me try to find my email. Oh, here we go. And it's giving you more than one.
Yeah, so it has 3, and they all just about say the same thing. So you said the $90 includes the text and the 85 doesn't, but I have 2 85s.
Right, but the one with the text is just the ebook, but within the assignments you have text with it. You understand what I'm saying? The how to or whatever. So you really don't need a book unless you just want to have something to have as a guide or whatever, or read through, but you don't really need it. You know what I'm saying?
Okay. So I have the image right here in the chat.
Oh, let me go back to the Zoom. Let's see. Well, where am I? My screen at? Okay, let's see. I gotta get to my, okay. Let me go to the chat. Me and this thing here, okay. All right, oh, let's see, okay, I'm gonna download it. Download it to, download. Okay. Okay. All right, let's see. 7-9.
So do you think I should just choose between the bottom
Hold on,
two?
hold on, let's see.
I don't
Oh,
wanna
and,
get into
and
the wrong
I got
class.
BRCC. Yeah, well, both of them got BRCC.
Right.
78365. Either one of those should work, but I'm wondering why are they different.
Well, I do notice the second one doesn't say Excel.
It doesn't. Let's see. Yeah, but it says Office.
Right.
Yeah, do the first one. Do
The first
Office.
one?
I mean the second one.
Oh, the second one. Okay.
But see, the first one, it just say Office. I mean Excel. So it look like it's just, why? Just Excel. See, because it should say
Excel and-
Microsoft Office is a Word, Excel, Access, and PowerPoint. You know what I'm saying?
Right. So I'm saying the first one doesn't say Office and the second one doesn't say Excel.
Right. But
we
do the
need
first.
both?
No, but we have our class 1503, and it's just a straight Excel class. It's an advanced Excel class.
Oh, okay. Okay.
Right,
So that's
right.
a different class. So I want the Office, not the
Right. Yeah.
Got
Do
it.
the Office. Right.
Okay.
Yeah.
That was my question. Thank you.
All right then. Yeah. And do that one, man. Yeah, that is, and it's kind of confusing. Yeah, they need to separate or put the name of the course like on that first one, or the number of the course.
Yeah. So I'm gonna go ahead and go through that. I think that's all I need.
All right then, man. And like I said, them dates is all the way to the end. But if you go to modules, you'll see week by week what it is. Oh, week one, I think you got week 1, and then 2 through 8, and then 9 through whatever. So it have them broken down in that fashion.
Okay. Cool.
All right then. Yeah.
All right. You have a nice day.
All right, you too. Boom.